Hi, today we're looking at section 3.1, Graphing and Writing Inequalities. Take out something to take notes on, and if you have your concrete details and your check it out sheet, get those out so you can do your work on those problems, on those pages. But again, taking notes is very important. We have two learning targets today. The first one, I can identify solutions of inequalities with one variable, and I can write and graph inequalities with one variable. Our two vocabulary words we're looking at, first one is inequalities. Again, write these vocabulary words down in their definitions. Inequality, a statement that two quantities are not equal. And solution of an inequality, any value of the variable that makes the inequality true. Looking at inequalities, there are 5 signs that are used. The first sign is less than, and that's read A is less than B. Our second sign is greater than, and that's read as A is greater than B. The third sign is less than or equal to. It looks just like the less than sign, but it has the bar underneath it for equal to also. That's read as A is less than or equal to B. The next sign is greater than or equal to. A is greater than or equal to B. And the last sign is not equal to. A does not equal B. So let's now describe our solutions using words. So we want to determine the solutions for the inequality x minus 6 is greater than or equal to 4. So we have a table here. We randomly pick some values for x, -3, 0, 9.9, 10, 10.1, and 12. And we're going to see if those are solutions or not. So -3. Plugging that in for x minus 6, so -3 minus 6 is -9. Is -9 greater than or equal to 4? The answer to that is no. Trying when x is 0. We get 0 minus 6, and that's -6. Is -6 greater than or equal to 4? And again, we get 0. Now pick some positive numbers. When x is 9.9, 9.9 minus 6 is 3.9. Is 3.9 greater than or equal to 4? It's close, but again we have to answer no. It's still less than. And for 10, 10 minus 6 is 4. Is 4 greater than or equal to 4? Yes, so we have a solution because 4 does equal 4, and that bar tells us 4 will be a solution then. And x is 10.1. We get 4.1. Is 4.1 greater than or equal to 4? Again, the answer is yes. And the last one we can check. When x is 12. 12 minus 6 is 6, and 6 is greater than or equal to 4. So again, notice we picked x to be both, we picked negative numbers, we picked 0, and we picked some positive numbers. Always pick some negative, test negative, 0, and positive numbers. So now what are our solutions? We want to describe those in terms of words now. So looking at our table, we see that when x is a number less than 10, -3, 0, 9.9, the value of x minus 6 is less than 4, and therefore it's not a solution. We notice that when x is 10, the value of x minus 6 is equal to 4 and is part of the solution. And then we picked values of x greater than 10. Those were also solutions. So our solution was going to be all real numbers greater than or equal to 10, and that's using our words to describe those. Now it is your turn. We have a table here. You want to describe the solutions of 2p is greater than 8 in words. We have a table. Just complete the table and do what we did in example 1. Write the solution in words. Here we have a number line. We want to say what are the solutions shown on the number line. A couple things to point out. Here we have an open circle at 6. An open circle means that that number is not part of the solution. Then you notice everything to the left is shaded. So our solution is going to be, we can write this as x is less than 6. Now we want to determine, is negative x plus 9 greater than 3 represented on the number line? Meaning, is there a solution on the number line where x is a number and it's going to be represented on this number line? looking at this, we substitute in 0. Again, if you can pick 0, try 0. So if this is true, it will be a solution. 0 plus 9, is that greater than 3? The answer is yes. So therefore, the solution is represented on the number line here. Now we're given some words here, some sentences here. How would you represent those algebraically and to graph those same inequalities? So the first one we'll start with is all real numbers less than 5. Algebraically, it's going to look like x on the left-hand side again, a less than sign, and the number 5. Graphing it, since it's less than, it cannot equal, it's going to have an open circle at 5, and less than is going to go to the left-hand side, shade everything to the left. The next one we're looking at are all real numbers greater than -1. In algebra, that'd be x is greater than -1, a greater than symbol. And graphing is going to be an open circle at -1 and shading everything to the right. It's got to be greater than -1. Our next one, all real numbers less than or equal to 1/2. There we have the less than or equal. So you need to pull in the less than or equal to sign with a bar underneath it. Graphing it, our circle changes from being open here to a solid circle or a closed circle because 1/2 is part of our solution. And our last one we're looking at, all real numbers greater than or equal to 0. So we're going to have x again on the left-hand side, a greater than or equal to sign, and 0 on the right. Graphing, you guessed it, a closed circle at 0 and shading everything to the right. So let's look at an example. Here we're asked to graph an inequality or two inequalities. The first one, m is greater than or equal to 3/4. So greater than or equal to means there's going to be a solid circle here and greater than everything to the right. And if you notice, our greater than sign goes the same direction that our shading goes when we solve for the variable. Our next example, we have t is less than 5 minus the quantity -1 plus 3. Oops, you notice that's not simplified yet. We need to go ahead and simplify this before we can graph it. Parentheses first, or grouping symbols first, so we get t is less than 5 times 2, and then which is t is less than 10. From here, less than means we're going to have an open circle at 10,